All right, welcome back. We're at 11.2, day 2, arithmetic sequences. Now we're going to determine the formula for the nth terms of an arithmetic sequence and find the sum of n terms of an arithmetic sequence. All right, so determining the formulas for the nth term in an arithmetic sequence, we've kind of done this already, but here we go. Okay, what is the general formula for the nth term of 4, 7, 10, 13, etc.? Okay, well, we already know our nth term formula, and that's a sub n equals a sub 1 plus n minus 1 times d. All right, so to figure out the nth term, we need to know the first term. We need to know d as well. All right, so, okay, now our first term clearly is 4 by looking at the list we have. All right, so that my nth term is going to be 4 plus. Okay, now again, it's an nth term formula, so I don't have a number for n, so I'm going to leave that as n minus 1. The other thing we need to figure out is d. Okay, and pretty clearly we can see if I'm going from 4 to 7, that's up by 3. 7 to 10 is also up by 3, and we can keep doing that all day. But basically what that lets us know is that d equals 3. So we basically throw the 3 down there. Okay, use parentheses, don't use parentheses, whatever sounds good to you. But anyway, there's everything plugged in as far as we can at this point. So basically now we just kind of simplify that thing down. So a sub n equals 4 plus, distributing the 3. Now, of course, if it bothers you to see 3 on the right-hand side, just write it on the left-hand side of the parentheses. But either way, that'll give you 3n minus 3. And then, of course, we can do a little bit of cleanup there. I like to put the variables first, so I'm going to write 3n first. And then the 4 and the negative 3 get together to make a positive 1. And then there's our nth term formula. Okay, now of course it's a decent idea to kind of plug in a n value and make sure you get the terms you want. So if I plug in 1, I get 3 times 1, which is 3, plus 1 gives me 4, which, yep, that's my first term. I plug in a 2, 3 times 2 is 6, plus 1 gives me 7, that's my second term. Yep, feeling pretty good. I got a good formula there. All right, moving on. So if we know the general formula for the nth term, we could then use it to find a particular term if we wanted to do so. So here we go. Determine the general formula for the nth term of an arithmetic sequence with a sub 1 equals 19 and d equals 4. Okay, so similarly to what we had last time, I've got my nth term formula, and okay, in this case I'm just going to go straight to plugging in numbers. So I got 19 as my a sub 1, okay, and then again I don't know my n yet. All right, because I want to come up with a formula first, and then I'll do something with that a sub 20. All right, and again, the d in this case, they're just blatantly telling us that's a 4. Again, to me, that looks weird without the parentheses, so I like to throw the parentheses there. But again, whatever sounds good to you. All right, so anyway, here we go. A sub n equals, okay, that's 19 plus 4n minus 4. And just like last time, we can do a little bit of cleanup here and get a sub n equals 4n, and then a plus 15. All right, so that's half of the things that I was being asked to find. Okay, the other half is using that formula to find a sub 20. Well, okay, so let's take that formula. Okay, so again, now a sub 20, notice that the 20 is telling me that n equals 20. All right, so a very important thing to recognize there. N equals 20 by that a sub 20 thing. So basically all that means for us is we're going to take 4 times that 20, the n value, and we're going to add 15 onto that, and a little bit of number crunching there. We get a sub 20 equals, that's really 80 plus 15, also known as 95. And so there's the second thing we're asked to find. All right, so anyway, that's how that goes. All right, now we can certainly do the same thing recursively to find sequences. Okay, now again, as you get used to the notation, this gets easier, but I know again, maybe a little, at this point you're still a little bit fuzzy on it, but let's kind of highlight a couple things as we talk about this here. Okay, so I want to determine the general formula for the nth term of an arithmetic sequence with a sub n equals a sub n minus 1, a sub n minus 1 minus 5. Sorry, I garbled that a little bit there. And then a sub 1 equals 8. Okay, now again, notice for the a sub n term, I'm taking a sub n minus 1, which again is just the previous term, and the only thing that's changing whatsoever is we're doing a minus 5. Okay, so I'm going to work a few terms out, but just looking at that minus 5 is the only change, should give you a big hint of what's going on. So here we go. Just writing out a few terms, I got a sub 1 equals 8. All right, and then again, I've got a sub 2 equals the previous term, which is 8, and then it's going to be minus 5, which gets me to a 3. So then the third term is going to be that previous term, 3. We're going to subtract 5 from that, and we're going to get a negative 2 from there. Okay, so notice what's going on here is from 8 to 3, we're dropping by 5. From 3 to negative 2, we're dropping by 5 again. So again, that minus 5 here, and again, it's because it's the only modification because in this formula. That's basically your common difference staring you in the face right there. So from all the messing around I've just done here and what I said, that means that d equals negative 5. And of course, that's going to come in handy for figure out an nth term formula. All right, so let's go back to doing that. All right, so here we go. So our a sub n is going to be our first term, which we know is 8. All right, we were told that in the problem. All right, then plus our good buddy n minus 1. Okay, and then here's where that negative 5, if you don't use parentheses there, it looks a little bit like you're trying to do a subtraction. So if this is the order you write things in, I very highly recommend using parentheses there. And admittedly, that's why I kind of like to use parentheses most of the time so that confusion doesn't occur. All right, anyway, that gives me a sub n equals, again, a little bit of distribution here, negative 5n, and then a plus 5, watch your signs. And so my nth term formula works out to be a negative 5n plus 13. All right, so basically, see, we can turn a recursive formula or a recursive definition into a nth term formula with a little bit of playing around. All right, now from there, we want to find a sub 25. So here we go, a sub 25. Again, that means that the n value is 25, so it's basically just negative 5 times 25 plus 13. And then crunching those numbers gets me a sub 25, or again, the 25th term in the sequence, as negative 112. All right, and there you go. Okay, so again, don't let that recursive definition scare you. It does give you a lot of good information if you know how to read it. Okay, so moving on to the parentheses partial sum in an arithmetic sequence. Okay, so as it says below that, our book doesn't mention it, but since arithmetic sequences go on forever, they all either add up to infinity or negative infinity, depending if they're getting bigger or smaller. However, we're going to add up just the first n terms, so we're only finding a sum of a part or a partial bit of the infinitely long list of numbers. Now, some books call this a partial sum. All right, now ours doesn't, but again, if you ever see the phrase partial sum, don't freak out. They're just saying, hey, instead of adding an infinite long list, we're just going to add some of them. All right, so anyway, for example, what is the sum of 1 plus 2 plus 3 plus 4, all the way up to 100? Okay, now you might think you're going to have to wear out your calculator to do that, but brace for impact, it's actually not quite so bad if you put a little bit of thought behind it. All right, so for instance, let's take the first term and the last term. Okay, well, if I take 1 and 100, that's 101. And then if I take the second term and then the second to last term, well, 2 and 99 is also a 101. And then if we do that with 3 and 98, again, notice we get a 101 again. All right, so since my list is 100 numbers long and I'm pairing up all of them, that means I have 50 pairs. And every single one of the pairs, if I continue doing it this way, is 101. So really all that it takes to find this list of a huge list of numbers here all added up together, it's as simple as taking 50, half the length of the list, times 101, which is basically just either the first time plus the last, not times, first plus the last, or the second to the second times the second to last, etc. But then that equals 5,050 if you crunch those numbers. All right, so actually it's a pretty simple thing to do if you can kind of make things into a pattern that works for you. All right, so the result from that last example can be generalized into a formula for the sum of any number of terms for an arithmetic sequence. Now, critical that it's an arithmetic sequence. If it doesn't follow that pattern, then this formula will not work. All right, so here we go. Here's the formula, the partial sum of an arithmetic sequence. Okay, for an arithmetic sequence with first term a sub 1 and nth term a sub n, and for our purposes, the nth term here we're going to consider like the last term because that holds a little bit better meaning for the sake of what we're doing here. But moving on, the sum of the first n terms of the sequence is given by s sub n equals, all right, works out to be n over 2, parentheses, a sub 1 plus a sub n. Okay, now if you look at what's going on, that n over 2 is, again, the number of terms in the list cut in half, just like that 100-term list we had. We cut that in half to make the 50. And then a sub 1 plus a sub n, which, again, is the first term plus the last term, is like having the 1 plus 100 that gave us that 101. All right, so that's what's going on with that sequence. All right, moving on. Okay, so let's put it to use here. Find the sum of the first 40 terms of an arithmetic sequence, 5, 11, 17, 23, etc. All right, so here's what we need to know for our formula. Okay, so the sum, well, let's see, it's 40 terms, so that means n equals 40. So I can say s sub n, or sorry, s sub 40, I meant. All right, and at that point I start plugging things in. I got 40 over 2, that's the n over 2, that, excuse me, works out pretty well. Okay, then we need our first term, which is 5, because again, it's sitting right there in our list. All right, plus our nth term, or our last term, in this case the 40th term, and that's what we don't know. All right, so we need to figure out that 40th term, but hey, we've got a formula for that. All right, so kind of over on the left here, let's figure out a sub 40. All right, again, that's going to be our first term, which is 5, plus n minus 1, which in this case n is 40, so technically 40 minus 1, again 39, but again just to show the formula. And then for our list, we can see from going 5 to 11 and then 11 up to 17, we can clearly see the d equals 6 right there. All right, so throw that 6 over there, and we crunch a few numbers, and we get a sub 40 equals, and that works out to be 239 after doing all that number crunching. All right, now of course that 239 is what we can then throw into our formula over here. So 239, and so crunching some more numbers over there on the right half of the screen, we get the s sub 40 equals 4,880. Okay, now again, your comfort level with being able to type things into your calculator. If you can't do that all at once, of course, do it in bits and pieces. You should eventually get the same answer either way. So there you go. All right. So the book's going to ask for a couple other ones in a little bit weird ways, so I think I'm going to do those as part of this video, just so that you don't get confused by some of the curves they throw you here. But anyway, here we go. Find the sum of the first 75 positive integers. Okay, well, if I'm talking positive even integers, I'm going 2 is the first one. Now remember, 0 does not qualify as positive. It is the only unsigned number that we have. It's neither positive nor negative. It's kind of neutral, so to speak. All right. So anyway, we start with 2 then, and we go 4, 6, 8, etc. Okay, so that's what we're working with. All right, so again, if I start thinking of the sum of the first 75 positive even integers, I can start saying, okay, well, the sum of the 75 terms, because, again, 75 of them, I guess I probably should have said this earlier, but that pretty clearly says that n is 75, because there's 75 terms, and n is the number of terms. All right, so anyway, s sub 75 is then going to be the n, which is 75 over 2. Okay, and then our first term is 2. And then plus, well, yeah, we get the same problem we had in the last one. We don't know what the 75th term is. Now, admittedly, here, you might be able to pretty well figure it out quickly. But again, sometimes these things are counterintuitive. So let's go through the work. All right, a sub 75 equals first term 2 plus the n, which is 75, minus 1, times our common difference. And again, maybe blatantly obvious here, but of course if I'm doing 2, 4, etc., that means my common difference is 2. All right, so you throw that together, and that gives us a sub 75 equals, and you probably guessed this already, and this is one of those that does actually work out the way you predicted, 150. Okay, so again, throw that 150 over on the side there, and that gives us s sub 75 equals, and a little bit of number crunching gets us 5,700 for that guy. All right, there you go. So again, you do have to play around with the formulas a little bit, dance between the two different ones to eventually get the sum, but it does work out just fine. Alrighty. Okay, last one here, I believe. Yep. Okay, we're going to find the sum of the odd integers between 16 and 80. Now, the first thing that jumps out at me is they said odd integers between 16 and 80. I'm like, hey, those are even. Okay, well, I think what they're trying to do is avoid if they said between, let's say, 17 and 79. Well, then the question is, well, do I include the 17 and the 79, or do I not? So they're given the even numbers in this case just so that there's no mistake about which ones we need. So basically what it means is we're doing 17, and then we're going to go with 19 and then 21, and we'll keep going up until 79. And then, yeah, it's very obvious which ones we're talking about since we were asking it in this way. All right, so again, we're trying to figure out our sum, so we want s sub, wait a minute, we don't know what the subscript is. That's a problem. All right, so again, I don't know what n is, and I'm going to put that over 2. Now, the good news about this one is I do know the first term, 17, and I do know my nth term or last term, which is 79. Again, the problem is I don't know what n is. All right, but the good news is our nth term formula will get the job done. So I'm going to write it out with all its variables in place real quick first, just to kind of highlight what's actually happening here. Okay, so there's our formula. All right, so let's see what we have. Well, the 79, again, is our last term, so that's our nth term. So that's going to go in place on the left-hand side, because that's kind of like our final term, if you will. All right, now a sub 1, our first term, that is staring us in the face, is 17. All right, now again, I don't know what n is, so n minus 1 stays exactly as n minus 1, but the common difference of 2, just kind of like the last one we did even numbers, with the odd numbers here, pretty much same thing, n is going to be 2 as we're counting up by 2's. All right. So notice here we have an equation that only has one letter in it, specifically the n. So we can solve that using our normal equation solving stuff. So 2n minus 2 over there, a little bit of combining like terms, gets us 2n plus 15. Subtracting the 15 gets us a 64 equals 2n, and then ultimately n equals 32. All right, So now we've got what our n value is. So now we can go back to our nth term formula, or sorry, our sum of the n terms formula, get a 32 there, and that 32 also then jumps up on top of our fraction as the number of terms. Okay, now we've got everything in place. So the sum of those 32 terms, which again we didn't know it was 32 when we started this, but now we know it's 32 terms, works out to be 1,536. So there's how that all plays out, depending on which information you're missing. That's what you can do. All right, as always, I hope that made a whole lot of sense. But as always, if it didn't, please ask for clarification in class, and I will see you there.